In the quest for cleaner and more efficient energy sources, engineers are now reaching new heights in wind turbine technology. With skyscraper showdowns, the epic race for the world's tallest turbine, the era of super-tall wind turbines has dawned, and structures soar above some of Europe's tallest skyscrapers. These colossal turbines are not only reshaping the skyline, but also redefining our approach to sustainable energy. How did we arrive at this engineering marvel? What's driving the fierce competition to build the world's tallest turbine? Is it a race anyone will win? The race is on to construct the world's tallest wind turbine, with prototypes surging in height over the last 3 years. As these structures grow, questions arise about their limits and the engineering marvels that make them possible. With power generation from wind surging globally, larger turbines are emerging as key players in the transition to greener energy sources. The race for the tallest turbine is all about maximizing efficiency. The strategies involve increasing rotor size and elevating turbines to where the wind blows consistently. These innovations are transforming wind energy from a niche solution to a competitive powerhouse, capable of producing electricity at cost below traditional forms of power. The wind turbine erected in Denmark at the beginning of 2023 stands as a towering testament to human engineering prowess. Soaring to an impressive height of 280 meters, it surpasses all others on the planet, at least for the time being. What sets this turbine apart, however, is not just its unprecedented height. Its rotor diameter, a staggering 236 meters, dwarfs iconic landmarks like the London Eye by a substantial margin. The turbine's colossal blades, each stretching an impressive 115 meters, outshine even the famed Big Ben in size. Crafted with precision, these enormous blades were meticulously assembled at a nearby blade factory in Knoxgolf, and then transported to the site, a feat of logistical coordination in itself. The energy potential of this behemoth is nothing short of awe-inspiring. Just a single turbine of this magnitude has the capacity to generate a remarkable 80 gigawatt-hours of energy annually. To put this into perspective, it is ample to power around 20,000 European households for a year. Yet the environmental benefits don't stop there. By harnessing this wind energy, the turbine contributes to a significant reduction in carbon emissions, saving over 38,000 tons of carbon dioxide each year. This is equivalent to the positive impact of removing a staggering 25,000 passenger cars from the road annually, a testament to the immense potential of these towering structures in combating climate change. A mere couple of decades ago, the UK celebrated a significant achievement in renewable energy by constructing an offshore wind farm. However, this pioneering project could generate only a fraction, less than 3%, of the energy produced by Denmark's latest towering turbine. This notable difference in output illustrates the remarkable progress and technological advancements in wind energy. Given the stark contrast in capacity, it's no surprise that these colossal wind structures are rapidly becoming more prevalent as nations seek to harness the full potential of wind power for their energy needs. Not content with the impressive heights achieved by Denmark's turbine, Germany is now pushing the boundaries even further. In a bold move, engineers in Germany are testing the limits by erecting a colossal 300-meter-high testing mast, signaling a new frontier in wind turbine technology. Behind this ambitious project stands Sprine, a pioneering company that foresees these high-altitude turbines as capable of doubling the electricity output of their smaller counterparts. Furthermore, they envision the possibility of integrating multiple turbines at varying heights, a concept that is also being explored by the Norwegian innovators at Wind-Catching Systems. These groundbreaking endeavors reflect a global ambition to maximize the potential of wind energy and establish more sustainable sources of power. The audacious proposal of a 300-meter by 300-meter offshore wind farm represents a monumental leap forward in wind energy endeavors. This colossal square, dwarfing even the iconic Eiffel Tower, is set to be situated out at sea, harnessing the formidable power of ocean winds. The sheer scale of this project is awe-inspiring, with the potential to generate as much energy as 5 of the most powerful floating turbines currently in operation. It's a testament to human innovation and the relentless pursuit of sustainable energy solutions. The impetus behind this race to construct ever taller wind turbines is grounded in the urgent global need to transition to greener energy sources. The imperative to reduce carbon emissions and combat climate change has never been more pressing. For years, wind power was viewed as insufficient to meet the demands of large-scale energy production. However, a paradigm shift has occurred, driven by advancements in technology and engineering. In just the past year, power generation from wind sources has surged by a remarkable 17% worldwide. Over the last decade, wind power has quintupled, a testament to the strides made in this field. These remarkable achievements owe much to the development of larger turbines, capable of extracting more energy at a lower cost. Nevertheless, there remains an unyielding quest to push the boundaries, driven by the desire to maximize the potential of wind energy and create a more sustainable future. The process of extracting more energy from a wind turbine is a multifaceted endeavor, and it revolves around two key approaches. The first entails enlarging the rotor and blades, effectively increasing their diameter. This strategic augmentation allows the turbine to capture a greater volume of wind energy. The second involves elevating the wind turbine to higher altitudes where the wind tends to blow more consistently and with greater force. When these two methods are synergistically employed, the result is an optimal configuration for harnessing wind power. The impressive outcome is that these colossal wind turbines not only have the capacity to generate an extraordinary amount of energy, but also achieve this at a lower cost. For instance, the 250-meter-high offshore wind turbines in the UK have demonstrated remarkable efficiency, producing energy at a cost of less than £50 per megawatt-hour. This cost-effectiveness is instrumental in rendering wind energy competitive with other conventional forms of power generation. Notably, these towering turbines have blades surpassing even the size of the iconic Big Ben. The scale at which they operate allows for an exceptional extraction of energy from the wind. However, as with any ambitious endeavor, there are certain challenges to contend with. As the blades grow in size, they become subject to engineering complexities, including stability concerns and the necessity for robust support structures. Despite these hurdles, the potential for even larger and more powerful wind turbines remains a tantalizing prospect for the future of renewable energy. As wind turbine blades increase in size, there is a crucial limitation to consider. To prevent erosion and structural stress, the tips of the blades must not exceed a rotational speed of 90 meters per second. This safety measure implies that as the blades become larger, they must rotate at a slower pace. However, this adjustment introduces a new challenge. The slower rotation necessitates an increase in the overall weight of the turbine, which in turn escalates the cost of constructing and maintaining the entire structure. Ultimately, there exists a critical threshold where the expense of building and operating a larger turbine outweighs the potential profit it would generate. This economic ceiling presents a practical constraint on the size of these colossal structures. Moreover, from an engineering perspective, as blades extend in length, they inherently become more susceptible to wobbling, especially in high winds. This poses a significant control and stability challenge. Nevertheless, experts hold an optimistic outlook, anticipating that innovative design solutions will eventually overcome these hurdles, potentially paving the way for even larger and more efficient wind turbines in the future. One of the critical aspects of wind energy generation is the location of the wind turbines. In this case, the most ideal location for these gigantic wind turbines happens to be the middle of the ocean. This area is known for having consistently strong and steady winds, making it a prime spot for harnessing wind energy efficiently. You might be curious about how these massive structures manage to stand in open water. Unlike traditional turbines that are anchored into the seabed, these super-tall wind turbines are designed to float. They are strategically positioned in waters deeper than 60 meters, where they are anchored to the seabed using multiple moorings. This innovative engineering approach allows them to remain stable and functional even in the challenging conditions of the open sea. Interestingly, the concept of floating wind turbines draws inspiration from the engineering techniques used in floating oil platforms. These platforms are designed to stay afloat in the middle of the sea, while accommodating various equipment and machinery. The knowledge gained from the development of offshore oil platforms has been applied to create floating wind turbines. allowing them to withstand the dynamic forces of the ocean. As turbine blades reach monumental proportions, engineers grapple with stability and control. While longer blades extract more energy, they pose challenges in managing wobble and wind forces. Additionally, the logistics of shipping and assembling these megastructures offshore present formidable hurdles. The UK, for instance, faces constraints in manufacturing and assembling turbines fast enough to meet ambitious renewable energy targets. As technology advances and logistical challenges are surmounted, even taller skyscraper-sized wind turbines may soon grace our horizons. Enormous wind turbines of this scale are set to become more prevalent in the battle against climate change. The key priority is optimizing their efficiency to maximize energy production. Consequently, it's likely that we'll witness even taller wind turbines, reaching heights comparable to skyscrapers in the foreseeable future.